All right. Hey, everybody. My name is Sam Dozor, and I want to talk to you today about integrating SDKs, strategies, secrets, and automated testing. So I don't know how many of you here are app developers. I'm an SDK developer, but there have been other talks here at Droidcon and other conferences about how to create an SDK. So I'd like to sort of talk from the perspective of app developers and how you should be looking at SDKs and vetting SDKs and thinking about these services that you integrate with. So first thing I'd like to talk about is to sort of give you some context into the problem. So businesses today increasingly rely on their apps to deliver their product or experience to the end customer. Apps aren't just companions or add-ons to a business. More and more so, they are the business. The mobile app ecosystem has exploded with hundreds of services. So these analytics, attribution, A/B testing, push marking, developer tools. So the first thing I'd like to chat about today is the array of these services and what it means to create a data strategy for a modern mobile-centric business. So, what can you do? The second thing I'd like to talk about today is what you can do to vet these SDKs. These services may fall into different categories with different goals and feature sets, but there are common threads between them all. Many or most of these services surface an API that can consume the data from your app. And many or most of these services not only provide an API, but they also provide client-side SDKs that help you implement that API. This is obviously a simplification. Most SDKs are more than just clients to an API, but so that's the second I'd like to cover. What all goes into an SDK? What are the common threads to look out for? And what should you as an app developer, assuming some of you are app developers and not just SDK developers, look out for when you're evaluating whether or not to include an SDK in your app before you even put it in. So yeah, I want to arm you. I don't want to be too pessimistic about SDKs. I myself am an SDK developer, but I kind of want to arm you with the questions that you should be asking. And so assuming that you've chosen an SDK and you want to try it out, the third thing I want to talk about is what you should do once the SDK is in your app to mitigate its risk and to test it. SDKs and external dependencies in general present an interesting engineering problem in that the moment you accept an SDK into your app, not only do you have to worry about your own code, but you have to worry about the code of the SDK. Many or most of you, I assume, test your apps. Maybe a subset of that, hopefully a large subset, perform automated tests of your apps. And maybe a smaller subset still have sort of a full test suite with integration tests and unit tests. And depending on the size of your org and the size of your team, you may or may not have time to do all these things. But the point is, you should be doing these things, whether or not you have the time to. For all developers and teams on that spectrum, you have to think about how can you maximize the quality and minimize your testing time. And the tricky part is, when you're adding an SDK, you don't want to have to spend time testing it. That's sort of like the SDK developer's job, right? They're supposed to give you something, it's supposed to work perfectly. But I'm here to tell you that, despite that, show of hands, has anybody ever had an SDK crash their app? Or yeah. So it happens, right? So the truth is, I would propose it's feasible to actually do some testing of these SDKs without spending too much time on it. And I think even more crucially, as a consumer of an SDK, it's up to you to hold these SDK developers to your quality standards. They might be in a different org, different team than you. They might have different practices than you. But the fact is, if it's going in your app, right, it needs to be up to your quality standards. So yeah, I'm just going to finish up the talk briefly talking about some of the things I do at mParticle to analyze these SDKs and to automate that analyzation. So all of us here at Droidcon are here for a number of different reasons. Maybe you're interested in learning more about Gradle or the latest build tools. Maybe you're interested in learning more about the nuances of Android itself. Maybe you just want to have fun days in New York. I won't judge. That said, I think or I hope that there's a sort of a common thread among us that we want to build better apps. And what I've been focused on these past few years is how we as app developers can better use our customer or first-party data to make smart, informed decisions to help improve our apps and grow our respective businesses. So some common links between all these tools are that they need access to your data to work. Many of them provide SDKs to do so, to make that easier for you. Not sure if anybody in the room has seen mParticle's periodic table of app services, but it's something that we put together last year to help make sense of this amazing ecosystem of innovative tools. There's been so much money, billions of dollars in the last few years invested in this ecosystem. And so what are these tools? Developer tools like Fabric and Crashlytics and Flurry, Hockey App, analytics tools like Google Analytics, Amplitude, mobile marketing like AppBoy and Urban Airship let you do stuff like Push, mobile media and multi-channel marketing tools to help you drive growth. It's really incredible and sort of dizzying how many of these there are. And what we found in our research is that apps are sort of adopting these services one at a time. So say you have one problem, one thing that you want to address, and so you add one vendor to address that one problem, right? And then you find another problem, and you add another vendor to address that problem. And you do it again and again and again, and before long you end up with an app that's just brimming with SDKs and external dependencies and risk. Rather than that strategy, at mParticle, we think that it's really important that you should come up with a more holistic strategy, right? Like take a step back, think about like what really are you doing with this app, and like what are your business objectives? What are the KPIs that matter to your business, right? If your business is based on your app, right, or your app is based on your business, you really should align your business objectives with the services that you use in your app. So part of this mobile data strategy starts with your business objectives, and then sort of moves on to the data itself, right? Accounting for native mobile data. Companies that may have traditionally been have maybe a web presence or even a physical presence, and now they have, last few years, they have an app. Their analytics team might not necessarily be accounting for the unique experiences that happen in a mobile app and think about the goals that they want to accomplish sort of in the context of that mobile app in Android. Naming conventions are an interesting thing when it comes to analytics. A few years ago, working at a company called Voxy, there's this other platform out there. I don't know if you guys have heard of it. I think it starts with an I. And there's these other developers who may even sit close to you. And if you're developing some feature, and there's some KPI that you'd like to track, some user interaction you'd like to track, you might focus on writing the code for it, shipping it, getting it at the door, and then at the last second, tagging, some important event, or maybe just tagging absolutely everything. And the iOS developer, sorry, I said it, calls it one thing, and you call it another thing. So before even doing that, I would propose you come up with naming conventions. This is like pretty basic stuff, but when you're grinding, at a startup and you're working fast, it's just sometimes not possible. So I just want to drive home how important that is, that when your analytics team goes to really analyze your data, if it's all over the place, they'll get nowhere, and what's the point what's the point of even having analytics if you can't actually use it? So yeah, some other things that go into this mobile data strategy: user IDs. What are the user IDs that you are looking to collect in your app? And all these SDKs, a lot of them have similar semantics around this. If your app collects Google ID or Facebook ID or IDFA in the case of iOS or Google Ad ID in Android, when you're thinking about your data strategy, think about all these IDs and what you can do with them. Tech alignment, that sort of goes along with the naming conventions point that, speak to your team when you're assessing these services. Chat with the other side of the aisle and think about what you and the other developers think are the best service. And finally, privacy controls, which I'll get more into in a second. Every SDK can potentially impact the privacy of your user. Once you give that SDK a context object and you instantiate it, it has access to everything. It can really do a lot of good, and it can do a lot of harm. And again, I don't want to take too pessimistic a view of an SDK. I create an SDK myself, but just to arm you here. Okay, so if I've made the case that SDKs and these services are important, the thing that starts, or where I sort of start when I'm thinking about adding a service, I think about a couple things. How long would it take me to build this myself, right? Like, do I even need an SDK for this purpose? A lot of the cases, the answer is yes, but maybe not. What's the cost of maintaining this thing if I build it myself? What's the likelihood if I build this that from a year from now I'll still be using it? Which of these third-party services out there are actually meant to accomplish this goal? And so all these questions sort of point to the notion that this huge mobile app ecosystem, it really does provide a lot of value. And these SDKs that could be potentially harmful to your app, ultimately if they accomplish some business objective that lets you get that done quickly, maybe they're worth the risk. Okay, so having made the case for SDKs, before even sticking an SDK in your app, I think there's a few things you should do to sort of assess it. And us as app developers, we might have a marketing team or a product team that tells us, hey, I want to use this new tool. And I think it's really up to you to make your voice heard, so that they know your honest opinion of, will this SDK really help us? It's going to hurt our app. So I think the first validation starts with the source code. And something that is sort of near and dear to my heart is the question, are they open source? I think all SDKs should be open source. Maybe that's a little bit of an opinion, but the way I look at it is most of the intellectual property of these services lives on the server side, and if you're going to be putting, a bunch of bytecode into your app, that you don't even know what it does, I just don't really see like a great reasoning why a company wouldn't at least open source their SDK, even if they're not willing, even if they don't want to treat it like an open source project and take like a bunch of PRs, you should at least be able to audit the source. So questions you should be asking, even if you can't see the source code, right? And maybe if they're not open source, the company is willing to share the source with you as a customer. But even if you can't see the source, you can ask them, how big is the SDK? How many methods is it going to add to my app? Even in the presence of multi-decks, it's still a pain to hit that limit. And even if you don't hit that limit, it's a pain to increase your build time, every time it needs to redex a library. My general litmus test is about 200 kilobytes. If you look at a jar and it's 200 kilobytes or more than 200 kilobytes, that's a lot of bytecode. I've seen some SDKs that have a lot of interaction with views and have a lot of custom classes that you can use as utilities. And maybe that's a reasoning to be more than 200 kilobytes. But if it's essentially implementing an API and a network layer, I don't know why it should be more than 200 kilobytes, or I just haven't seen why. What's that SDK starting strategy? Can I call all of its methods from the main thread and not worry about jank? Really the most an SDK should be doing when you call one of its methods is possibly reading from persistence. Anything more than that, and they should have been delegating it to a low priority background thread. So related to privacy from earlier, what are the types of data that the given SDK, what does it collect? And this is sort of specific to the attribution space, where attribution providers, if you're not familiar, are focused on driving ad campaigns such that you can figure out, okay, if this user clicked on this ad and then installed the app and then opened the app, right? How do they attribute that original click back to the install, right, or vice versa? And traditionally in Android, they've done all sorts of crazy things to get this done, and iOS is sort of famously sort of cracked down on this. Android's still the Wild West. They won't reject your app for doing things like collecting the MAC address and collecting IMEI. I've seen some SDKs grab all the shared preferences of your app and send it to their server, which may be actually an extremely useful feature. So there are SDKs out there that they say, oh, we'll auto import the other events that you're tagging. That actually is useful, but you need to know that they're doing that, right? Another thing that I've seen is related to attribution is grabbing the user agent. So prior to Android 4.2, there was no way to grab user agent without actually instantiating a whole web view in the background. So it's actually still pretty common that a lot of SDKs you'll initialize them and you're showing the user their first user experience. This is super important part of the app, and there's a web view that's being created in the background, right? And if your app isn't actually using any web views, that could leak threads that will never be used again, just for the purpose of creating the web view. Android 4.2 and later, there's actually a static method that these SDKs should be using. So that's another thing to look out for. Android ID, last thing I'll talk about there is that in some markets like China, Android ID is actually still necessary to use, where Google Ad ID isn't available. But outside of that, there's almost no reason to use Android ID anymore, except possibly for anonymous analytics. But again, this is if you see an SDK collecting Android ID, ask them, what are you using it for? Maybe it's valid, maybe it's not. Final question here is, what's the networking strategy, right? So it would be silly if you spend all this time optimizing your app's network usage and then finding out that an SDK is constantly uploading, right? There have been a bunch of talks made by Google about how, pretty simple stuff, how you should let the cellular radio power down. And if you don't do that, it'll basically constantly be on. So if you spend all your time, using new job scheduler APIs, and then all of a sudden an SDK is just constantly uploading, that time is wasted. Sometimes it might be necessary for SDKs to upload all the time, and sort of an advanced SDK might take particular events that are important and upload them right at that moment, and then other events which are not really time sensitive, they'll choose to upload them later. So it's sort of another thing to judge SDKs by. And then this isn't really a specific question, but SDKs can have dependencies, and oftentimes they do. And some SDKs even purport to be open source, and then they have closed source dependencies, which is kind of a joke. So given all the SDK, look at the POM, figure out what the dependencies are, and if there's anything you need to be worried about there. Okay, so Android Studio and Gradle have made it really easy to include these SDKs in your app. And it's so easy to do that now. You just add one SDK, another SDK, another SDK, and I want to look at what happens when you do that. Just that one line, what could possibly happen to your app? Seems benign, right? But maybe not. So whereas in the past, a lot of SDKs or Java libraries were delivered via jar, more and more so every SDK is delivered via an AAR. So you guys are probably familiar with this, but AARs, can provide, essentially everything that your app, a lot of the stuff that your app can provide, right? So they have their, their Android manifest. So, a manifest that an SDK can have might define services and broadcast receivers and permissions, and it might have, intent filters for those services that you might have intent filters for. And so just by adding that one line in Gradle, you could end up totally changing your manifest. So one easy way to do this, one little pro tip is that Android Studio after a build will give you a sort of a manifest merger debug report. One thing I saw recently is an SDK that wasn't defining a min SDK version in their manifest, which is probably just like a silly mistake by a developer. But what that ultimately means is the hosting apps that use that SDK get all the permissions that or need to use. Basically, when you don't define a min SDK, Android forces you to have things like read phone state and write external storage, permissions that had to be implicit on those earlier versions of Android. So yeah, AARs can also include resources, and Gradle can attempt to prune these resources for you and shrink them, but you can actually get into a little bit of trouble there as well. So, you can just enable shrink resources true, which seems like a great idea, but a lot of these SDKs actually sort of do a dynamic lookup. So if you not only enable resource shrinking, but also enable strict mode, which means that Gradle will look for only the resource IDs that you are actually referencing and not referencing dynamically. So if you've enabled this feature, you could end up crashing SDK in production if it's looking up dynamically. So you should ask them, do you do dynamic resource lookups? Moving on with AARs, all SDKs should include ProGuard rules. In the past, you always had to sort of look up, okay, what are the ProGuard rules for this SDK, for that SDK, for that, and really shouldn't be necessary anymore because they can include their own ProGuard rules, and the SDK developer should know better than you about how to ProGuard their own app or their own SDK. So make sure that they have ProGuard rules. And then one final thing I'll mention is that Gradle plugins are really awesome, but they're also a little bit scary. Like you can, if you apply a Gradle plugin, it can basically, it can get hooks into before your bytecode is generated. It can basically hook into everywhere in your build process, which is really powerful for SDK developers, but it just raises the bar a little bit for the auditing that you do. So, just in an hour review, I think you could do a lot to look at an SDK and sort of like figure out just the litmus test before even spending time putting in your app. What are the possible caveats to this SDK? And I think it's important for us as app developers to give honest feedback to our team members about, what are these, what do we think this SDK is, and what's it going to do to us? What are the trade-offs? And speak to the SDK developers and give them that honest feedback, and maybe they'll change it for you. Okay, so if you've decided that you want to put an SDK in your app, there's still more that you should do to actually test it and how it interacts with your app. So first off, when you're adding an SDK, don't use wildcards. This is probably the worst case scenario. Even with semantic versioning, if somebody, this is like such a rookie mistake. If you do this in your build system, not only will you like increase your build times, but they could just break your build and you wouldn't even know it. SDK developers can change everything that we've talked about behind the scenes, from one version to the next. So this is just like a lot of risk. This is a little better, right? So theoretically, if the SDK developer is following good semantic versioning, they won't change their interface methods, and maybe good practice says that they won't change their SDK that much between minor versions, but you really don't know. So really, this is the best, right? Pin the version. So once you've got the SDK in your app, a couple things you should look out for are, how much heap space does the SDK use on startup? Almost every SDK is sort of like a one-time memory leak in your app. They maintain like a static instance of themselves. And if you're already experiencing memory pressure in your app, it's possible that even a lightweight SDK could sort of put you over the top. So you can use Android Studio's built-in tools to check out, okay, what happens in application on create. Like this might be like a common pattern where all of a sudden, everything you do in on create in the first like 20 seconds uses a tremendous amount of memory. And then the garbage collector, catches up and helps you. But, in devices with low heap or apps that, already are experiencing memory pressure, this could be a real problem. Every device is different. It's amazing that what I've seen, like one function might take like almost no memory on one device, and then on some random Samsung in some random country, it'll use like 10x more memory or something like that. So, try your best not to leave that to production and find it out in production. Although to a certain extent, Murphy's Law will help you there. But yeah, device labs, although time consuming, can be super useful there. Yeah, so I talked about this a little bit, but almost every SDK, requires being created an application on create. This happens at any time. Whether the user taps on your launcher icon or just like your broadcast receiver that's associated with your process gets instantiated. I also mentioned this before, but initialization of an SDK should really have to do a little more, if anything, than read from persistence. Maybe it needs to initialize something and it needs to read from shared preferences, but more than like 20 milliseconds or something like that, or 15 milliseconds, and the SDK is doing too much. And every other SDK method should, unless it's like a query or something, I'm generalizing here, but most SDK methods should be like that. So this is something that's really common across SDKs, is this super powerful but kind of scary interface. So what this does, if you're not familiar, is given a context object, you can register for callbacks for every single activity in your app, on start, on create, on pause, on resume, all the important lifecycle methods. And that SDK's instance of this interface will be called on the main thread. And the reason why SDKs do this is because the reason why the mParticle SDK does this, and a lot of SDKs that I've seen, is that on Android, there's no way to tell if an app is in the background or the foreground. There's no API for it. So at minimum, they need to keep a counter or a weak reference to an activity just to know if the user is even using the app. But SDKs very well may be doing too much during these methods, so it's important to include these, the profiling of these methods of your activities, within your instrumentation tests. Because SDKs depend on this, you will likely break an SDK if you don't follow the directions around this. So yeah, I mentioned this before, but network usage, super important. An SDK should balance upload frequency with battery life. And look to see if most SDKs provide some sort of customization options. Don't just throw it in. Think about, with my app, what's my syncing scheme? Should I manually be calling upload on this SDK if it has it? So yeah, that's a summary of just the questions that you should be asking your vendors about these SDKs, which are they're tremendously useful tools. And I don't want to be too pessimistic about it, but us as app developers need to be asking these questions and sort of hold SDK developers accountable. So audit the source code, profile the memory usage, ask about the networking strategy. unfortunately, I recommended that you pin the SDK, but that means that you need to test these things sort of every time you update the SDK. These things can change without you really knowing it. All these dimensions are always important. And I don't know about you, like working at a startup, you just don't have time to constantly be testing these things. So your goal should, obviously be to update these SDKs as often as possible, but try to mitigate your risk through automation. So brief background about mParticle is that we provide a single SDK, ironically, that lets you use something like over 100 different server-side integrations, right? So we wanted to build an SDK that would let you rip SDKs out of your app so that you can send data once to your server and then send it off to other server-to-server APIs, right? All of our integrations, we have maybe 120 of them, or 110 of them. So about 10 of our integrations are on the client side. So this means that we wrap these SDKs. And because we do that, that's why I've been super obsessed with looking at these SDKs and reverse engineering them and understanding how they work and understanding the possible risks that they could present to our customers. So we have these sort of kit SDKs that wrap a third-party SDK and depend on our core SDK. And what we do is perform automated testing on these SDKs so that we can constantly be updating the pinned version that we're depending on, but giving a level of guarantee to our customers that what we're giving you is safe. Just to help you guys out, hopefully this is useful a little bit. When we were trying to solve this problem at mParticle, the first problem is, how do you know when there's an SDK update available? There's a bunch of different ways to do this. You can manually do it if you want. You can use a wildcard and see what it pulls down and then switch back to non-wildcard. But there's actually an awesome plugin out there that maybe some of you are familiar with called the versions plugin. And it just spits out a really useful JSON. It adds a task to your Gradle project, and it spits out really useful JSON or XML or whatever that will tell you, given your dependencies, what updates do they have, what versions of what updates. So if you've sort of solved that problem, the next thing you can move on to is, how do you automatically build your app against the latest SDK? And so I'll show you a version of what we use at mParticle, which is just a custom Gradle task. So you can wrap your dependencies, for example, in some function that maybe parses the output of the versions plugin and basically just returns what the latest version is. So that's just a simple example. And then sort of once you've already done this, so once you have that in your pipeline of, okay, there's an SDK version available, I'm building with it, how do you sort of automatically perform these tests? And there's another awesome GitHub project or Google Code Lab that you can use, that basically combines Monkey Runner. If you're familiar with it, Monkey Runner will allow you to run your tests and systrace in parallel, and let you get all sorts of battery stats and network stats. And specifically the meminfo command is sort of the most useful in SDK allocations. So that's the basic strategy that we followed in mParticle, right? Getting these updates, building them automatically, and you plug this all into your CI system, you can mitigate your risk and constantly be updating these SDKs. So that's about it. Just wanted to cover, give you sort of a field guide to how to look at these things, and what questions you should be asking, and the hotspots, and how to automate it. And that's it. Thank you.
So you have that table of SDKs, and I made my selection.
Yeah.
After I made my selection, at some point, I decided to change vendors. Yeah, this one. and I make my selection at some point, the company changed from vendor A to vendor B. Do I have to re-instrument my app? What do I do?
Yeah, I mean, it really depends on the vendor. It depends on your infrastructure. The whole thing that we sort of like aim to solve in mParticle is to avoid you doing that at all. And a lot of organizations that we work with have, they already have like an analytics pipeline that lets them just send us data server to server. And so if you if you invest in an infrastructure around your data, in a data plan, right, the things that you're collecting shouldn't necessarily change when you're changing these vendors, right? The two things should sort of be decoupled. So I don't know if that answers your question.
Do I have to change my code? I put the mParticle SDK.
Oh, well, in case of mParticle, no. Yeah, you don't have to change your code. That's the...
Hit the method count of an SDK.
So there are a few tools that you can use. I forget what it's called, but there's a few like open source tools out there. The slightly tricky part is depending on what the SDK's dependencies are, right? Like that SDK itself might have only a few methods itself, but you also have to look at the dependencies. But I can look it up after if you go to the tools, but there's like somebody's written a script for it. It's pretty easy. So just go through like that.
website called vectorcom.com or something similar. Will give you for every
Yeah.
publicly available SDKs and their method count for every common.
Yeah.
They have a plugin for grader that it will show you like which everything you have on the screen.
Oh, nice.
Yeah.
Awesome. Even better. So you can just like set like a threshold or something and have it fail the test.
It's kind of annoying though because like once they put there, it's difficult to change the version number because they keep like updating the line on the data file.
Right. Cool.
You mentioned you automate testing the SDK you integrate with.
Yeah.
Do you write your own test cases for those SDKs, and how is the covering look like?
Yeah. I guess I sort of breezed through it, but the important areas to test are cold start, initialization of the SDK, and I would propose also those application activity lifecycle methods. So in the new support library, there's actually no great way to test application. You still have to use sort of the old application class, which stinks, but there's a simple to use Android activity instrument or application instrumentation class that will let you just basically initialize the SDK, right? And Monkey Runner, in sort of that Google Code lab will let you say, okay, while this is running, it runs this trace a bunch of times and track what the allocations are. And then we sort of like automatically output like what the result is given a certain SDK, and then we manually look at it and say, okay, what's the deal with this latest update?
A follow-up question on that. So if you start a whole application, now how do you separate the impact of that SDK versus the impact of your, probably a wrapper application or some other SDKs?
Yeah, it's a good point. Like I think if you can, so at mParticle we create sample apps that only have the SDK in it. But another thing you could do is just like test the delta, I guess. So you could try testing with and without the SDK, or use like a mock class to like basically replace the SDK. Yeah.
So how do you mitigate like having a single point of failure? So now that you've done everything for your company, but you're doing all these SDKs for everybody.
Yeah.
How do you mitigate that risk?
Yeah, I mean, we never want to be like the single point necessarily. We want to like be just like part of your infrastructure, and because of that, we offer like a server-to-server API as well. But we typically recommend that people use like a separate crashing mechanism to like hold us accountable if they want. But also in mParticle, our goal is to like give you control over your data, right? So all of our 100 or so integrations, one of those is just like is just like dumping to S3, right? Or like putting it into like your data warehouse or Redshift. So, you know, we have no intention of like holding your data. You know, some of these systems you put your data into, it's like they're awesome and they're beautiful, but you can't like get it out, right? So we want to have you send it anywhere you want it to go. So that's one way to look at it.
How is that auto update strategy different than just using a wildcard?
Because wildcard, you need to check that into source. So you could do that, right? You could maintain a branch that just has the wildcard, but I've found that it's easier to check the auto update into source code, right? And just like in my CI server, say like whether or not auto update should actually occur, right? So like outside the build script itself.
Oh, okay.
Yeah. Yeah.
Another question. What kind of, I guess, what kind of control do you have in terms of defining how you update all the other SDKs that you guys integrate with? So,
Sure.
to your point about updating and keep making sure you're always updating, if you're relying on periodic, like do you have ways of tuning, like for certain integrations that will update more often and some that don't?
So yeah, like just with Gradle, for example, you can just disable transitive dependencies, and you can choose which version of. So we don't like vendor out any SDKs, right? We just use Maven dependencies. So in your Gradle script, if there's like a particular version of downstream dependency that you don't want to update to, or you do want to update to, whatever, like you can control it all in Gradle, right? As long as they haven't broken sort of semantic, like the syntax, you can choose whatever SDK you want. And the service we provide is that we try to like abstract that all for you. Right? But if you don't want to abstract it, then you can always work around it. Cool. Thank you guys.
Thank you.